Hello all, welcome back. So in this today's session we are going to designing the different types of the asynchronous counter. Another name for the asynchronous counters are the designing of the ripple counter, right? The first given question is that we need to design the 2-bit asynchronous counter, right? Then our another pattern of asking this question is design mod 4 asynchronous counter. By using which flip-flop we need to design? We need to design by using of the JK flip-flop. Right now they will be asking an exam point of view, either they will ask us to design 2-bit asynchronous counter by using JK flip-flop, or they will ask us to design mod 4 asynchronous counter using the JK flip-flop. Now first we will see, before going to implementation of the circuit representation, first we will see what is the meaning of mod 4 as well as what is the meaning of the 2-bit, right? The first point is that what is the meaning of the mod 4, right? So where mod represent the number of stages, right? The simple definition for the mod n or modulus n counter means it represents the number of states or number of stages. So what do you mean by this one? Right, suppose what is the given question, mod 4, right? 4 means how many states it will perform, or we can call it as the stages or counts, whatever it may be. 4 counts, right? It means that starting count will be 0 1 2 3, right? So this is what we called as the number of states or number of stages, right? So mod 4 means it is going to perform the 4 counting operation. So this is the 4 counting, right? So if you write in terms of the binary number, how it will be? Something 0 0, next state will be 0 1, next 1 0 1 1. So how many counts we have? 1 2 3 4. This is what we called as the mod 4 counter, right? So first we will try to write the, so now we understand what is the meaning of mod n or modulus n, right? Now see that the moment, what is the first count value? 0 0, right? The moment we apply the clock pulse, it will go to 0 to 1. After applying the second clock pulse, it will go to 0 1 to 1 0. After applying the one more clock pulse, it will go to the 1 0 to 1 1. After applying the final clock pulse, it will return back to the initial of the position, or initial position is the 0 0. This is what we called as the state diagram, right? So this is what we called as the state diagram, right? Now we'll see what is the meaning of the 2-bit asynchronous counter. Now see that what is the meaning of here 2-bit means, right? So 2-bit means how many bits value we need to store? 2-bit information, so, right? As we discussed so many times in the previous classes, if you want to store the, right, if you want store 1-bit information, 1 bit means either it may be binary number 0 or 1, we require how many flip-flop? 1 flip-flop is required. Now question is that how many bits we need to store? 2-bit, right? So 2-bit means how many flip-flops are required? Yes, we required the 2 flip-flop. It means that suppose I am going to take first flip-flop as the A, second flip-flop is the B. Nothing but if I am going to consider the 2 inputs are 2 flip-flops, how many possible counts you will be getting? Either it may be 0 0, 0 1, 1 0, 1 1. Now see that this is 2-bit we called as the, right? To store this 2-bit we require the 2 flip-flop. If we take 2 flip-flop representation, right? So how many counts it will perform? Either 0 0, 0 1, 1 0, 1 1, right? So this is what we called as the mod 4. Meaning of mod 4 means it will perform the 4 states or 4 stages. So how many bit representation we should have? 2-bit representation. To store the 2-bit value, how many flip-flops we require? 2 flip-flop. Why? Because 1 flip-flop can able to store only 1 bit information. Suppose if the question given question is something like this, right? So design mod 8 asynchronous counter. Now how many flip-flops are required? Try to identify if I want to design mod 8 counter. So mod 8 count means how many stages? 8 stages, right? If you want to write the 8 stages or 8 possibilities, how many bit representation we require? 2 power 3, right? 8 we can write. So how many bits we require? 3 bits we require. It means that if you take 3 bits, then count will be something 8 counts, right? It means that if you have the mod 8 or 8 stages, how many bits representation it is? 3 bits. So 3 bit means how many flip-flops are required? 3 flip-flops are required, right? The first step of designing of the asynchronous counter is that identification of how many number of flip-flops are required. So mod 4 means 4 stages. To perform 4 stages we required the 2-bit information. So 2-bit information we required the 2 flip-flop, right? So first step is completed, identification of the number of flip-flops. So which flip-flop we require? JK flip-flop is required. Remember this point. Next, what we have to do is we need to draw something called as the state diagram representation. State diagram representation means out of these 4 stages, how it will be changes from the one stage to the another stage. So what is the meaning of mod for 4 stages, right? So what is the first value? 0 0, second value 0 1, third value 1 0, fourth value is 1 1, right? So after applying the first clock pulse, what will be happen? Count will change from 0 to 1. Next 0 1 to 1 to 0, then 1 to 0 to 1 1. So once maximum count it reaches, according to the counter definition, it will return back to the initial position. So this is what we called as the state diagram representation, right? So now what we will do is we will try to draw the circuit diagram representation. As we discussed, how many flip-flops we required? 2 bit means 2 flip-flop required. Which flip-flops are required? JK flip-flops are required, right? Now we will draw the circuit diagram by using of the JK flip-flop, nothing but our step 3. Step 1, identification of the flip-flop. Step 2, drawing the state diagram representation. Step 3 is drawing the logic circuit diagram, right? So how many JK flip-flops are required? 2, right? Because we need to store the 2-bit information. So for that I am considering the first one, second one. For understanding purpose, I am giving the name of this flip-flop is A, this one is the B, right? So how many inputs we have? JA, KA. J, K actual input, but just we are identification purpose we are giving A, right? So this is called as the JA, KA. Now this is the B flip-flop, right? So what is the input value? JB, one more is the KB input value. So what is the output value? QA, QA bar. Here output values are for second flip-flop is QB, QB bar, right? So these are the input values, right? So these are the output values. Now we have the clock pulse also, right? Now based on applying the clock pulse, I have explained 2 things, right? One is called as the synchronous counter, another one is called as the asynchronous counter, right? So for this one I am considering the negative edge, for this one I am considering the negative edge. Now what is called as asynchronous counter? For the first flip-flop, right? For the first flip-flop, external clock pulse we need to apply, and remaining flip-flop, what clock pulse we need to apply? Output of the previous flip-flop. Then this is called as the asynchronous counter, right? The first flip-flop we are applying the external clock pulse, and the second clock pulse is nothing but the output of the previous flip-flop. Now this is called as the asynchronous counter, right? Now one more condition is that, now if you observe this one, this is important point to be remember. What is the first count value? 0 0, second count value should be 0 1, third count value is 1 0, final count value is 1 1, right? Now if you observe here, if count changes means 0 to 1 means, so here binary number is what? Changing from 0 to 1, right? Then only you are getting the count 0 to 1, right? Or if this number does not change, something like this. Next also it will be like this, then you will be never ever to implement the up counting or down counting operation. It means that if you want to change the one number to the another number, always your binary number should change either from 0 to 1 or 1 to 0. It means if you observe here, it is changing from 1 to 0, here it is changing from 0 to 1. Then only you are getting the count 0 1 2 3, something like this. Now here one more modification what we have to do circuit. If you want to perform either up counting operation or down counting operation, the binary value should change from 0 to 1 or 1 to 0, right? As I explained in the flip-flop operations, what is this we call? If binary number changes from 0 to 1 or 1 to 0, what is this condition we call? We called as the toggle condition. What do you mean by toggle condition? Changing the binary number from 0 to 1 or 1 to 0 is called as the toggle condition. Now question is that which flip-flop will perform the toggle condition, right? So if you understand what are the flip-flop will possess the toggle condition operation, the first flip-flop is the JK flip-flop, and second flip-flop is the T flip-flop. T flip-flop itself means toggle flip-flop. Now see that in JK flip-flop, what are the input condition we have? 0 0 0 1 1 0 1 1, right? Out of this one, this is not going to perform toggle, this is also not going to perform toggle, this is not going to perform toggle. But which condition is going to perform toggle operation? When J equal to 1, K equal to 1. In case if you are designing the circuit by using of the T flip-flop, right? So in which condition it will be? T equal to 0 or T equal to 1, right? So here it won't perform the toggle condition. For T equal to 1 only, it will perform the toggle condition. Now if you observe here, 2 bit means I have considered the 2 flip-flop, After that, to differentiate asynchronous counter, synchronous counter, I have given the clock pulse value. Right? Now, if the count want to change from 0 to 1 or 1 to 0, then only you will be getting the count something like this. For that, which flip-flop is required? Either JK flip-flop or T flip-flop. But as per the given question, we need to use which flip-flop? JK flip-flop. Right? Now, in JK flip-flop also we have the 4 condition, right? So, out of this condition, which will perform the toggle operation? Only J equal to 1, K equal to 1. Now, this condition we need to apply in the circuit so that you will be finding the asynchronous upcounting operation. Right? It means that what should be the JK value condition? JA should be 1, KA should be 1. Right? So, JA should be 1, KA should be 1. Here also, JB should be 1, KB should be 1. Right? Now, if you observe here, how many times we are giving external value? 4 times, right? For first flip-flop, 2 times external value. For second flip-flop, we are giving 2 times external values, right? Instead of doing like this, if I short this one as well as this one, I can give only single time, right? If I short this KA value with J value, I can give only single time, right? Again, if you observe here how many times we are giving? 2 times, right? So, if I connect something like this one, if I connected something like this, we can give as the only single time. It means that the moment if I are giving the value equal to 1, JA will be 1, KA will be 1, JB will be 1, KB will be 1. It means that it will perform the upcounting operation. Right? So, this is the circuit diagram for the 2-bit asynchronous counter or ripple counter, which will perform the 4 stages or 4 counts. Now, we will see the what is the operation of the 2-bit asynchronous counter. So, initially how many flip-flop? First let me explain the operation, then again I will explain practically. So, 2 flip-flop, right? So, see that first flip-flop output is connected to second flip-flop clock pulse. If JAK is connected to 1, if JBKB is connected to 1, then this is called as the asynchronous counter. Now, if you observe here, just give me a second. Now, if you observe here, so how many flip-flops outputs we have? One is called as this one, right? As we discussed here, how many flip-flops output we have? One is called as the QA, another one is called as the QB, right? The same way here also we can consider this output as the QA, this output as the QB. Now, see that what is the first initial count value or what is the value stored in the flip-flop 0, 0. The moment, as I said in state diagram, if you want to go from, right, 0 to 0 to 0, 1, what we should do is we need to apply the clock pulse value, right? So, after applying the first clock pulse, count will change from 0 to 1. Now, after applying the one more clock pulse, it will go to 0, 1 to 1, 0. After applying the one more clock pulse, it will go from 1, 0 to 1, 1. After applying the final clock pulse, it will return back to the initial position, right? So, this is the operation of the asynchronous counter. But if you want to understand what is the real meaning behind this one is, then we need to look into it, right? So, suppose for example, let us say, right? So, what is the operation I am taking? This is the first flip-flop value QA, second flip-flop value is QB. I am going to consider something called as the clock pulse value, right? So, initially I am not going to apply any clock pulse. So, 2 flip-flop means it will hold the 2-bit information. Let it be that information is 0, 0. Now, what I am going to do is I am going to apply the first clock pulse. It means that this external clock pulse is activated. So, after activating this external clock pulse, you will be getting the output for the QA. After getting the output for the QA, this will go to the clock pulse of the second flip-flop, so that you will be getting the output of the QB. Now, we will see what is the operation, how it will change from one count to the another count, right? So, for example, see what is the value here I have stored. So, let me take some other color so that you will understand clearly. Right? So, what is the initial value of the flip-flop 1? 0 as well as the 0. Now, to understand this one, we need to understand some more thing. The first clock pulse is nothing but the external clock pulse, right? That we are applying to the first flip-flop. Remember that external clock pulse means first time if you are applying this clock pulse, if the value is something, it is 0, right? 0, right? It will change to 1. It means that after applying the external clock pulse value, if output is 0, it will change to 1. Or if output is 1, it will change to 0. Remember this point, this is important. Because external clock pulse means manual clock pulse that we are applying the every time. So that if the output of flip-flop is 0, after applying the clock pulse, it will directly change to the 1. Or if output value of the flip-flop is 1, directly it will change to the 0. This point you have to remember. For what? Only for this external clock pulse. Again for the second flip flop, this is the clock pulse, right? Which clock pulse it is? Positive edge or negative edge? If you have the bubble following by the edge, it is called as the negative edge clock pulse. So negative edge clock pulse means simple thing. If it is positive edge clock pulse means it will change only. Positive means 1, negative means we can consider as 0. It means that negative edge will changes its output value of the flip flop only when it detects the 0. Suppose if it detects the 0, here it detects the 0. Now what will be happen means if the value is here 0, it will change to 1, right? Or if the value here it is 1, it will change to the 0. But here if it is detects 1, then this value will not be changed. If 1 means 1, 0 means 0. So from this, what is the point you have to understand here is that negative edge will trigger only for the 0. If whenever the second clock pulse is value is 0, it is nothing but the output of the QA is the second clock pulse, right? The second clock pulse is said to be 0. Then only flip flop 2 is there, right? Nothing but QB. If the output value means 0 means it will change to 1, or 1 means it will change to 0. But if the second flip flop value, right, clock pulse is 1, which is coming from the QA, then if it is 0 at the output of the second flip flop means it will be 0 only. If it is 1, it will be 1 only. Simple point to remember is negative edge will change only whenever it detects the 0. If detects the 1, it won't do anything, it just keep quiet. That point you have to remember. External means clock pulse means always it will change, but second onwards it detects 0 only, then only it will change from 1 to 0 or 0 to 1, right? Now we'll see the operation, right? Now after applying the first clock pulse, what will be happen? This is the negative external clock pulse, right? Always this value will change from 0 to 1 or 1 to 0, right? Now what is the answer of QA? This value is 1. Now see that this is the value 1 we got, right? This is nothing but QA output 1, right? The same value will go to here, right? Now see that this is value is 1, right? Now this value will change or not? Try to understand. See which clock pulse it is detect? 1 or 0? 1. 1 means this value will not be changed. If it is detect 0, then only this value will be changed. Right? Now what is the output of QA we got? Output of the QA equal to 1. Right? The 1 will go to here, means negative edge will not change for 1, so that this output value will be remains same, right? Now what is the output of the QA? QA value is the 1 that I am going to write on this table. Then second output QB will not change because it detects the 1, not the negative edge, nothing but 0, right? First clock pulse is completed. Now what I am going to do is I am going to apply the second clock pulse. After applying the second clock pulse, what I tell, for external clock pulse always it will change from 0 to 1 or 1 to 0, right? Now see that what will be happen this one, what is the current output value? 1, right? So for external clock pulse always it will change from 0 to 1 or 1 to 0. Now what is this value? QA value 0. Now if you observe, what is the output? 0, right? 0 is nothing but QA, right? QA is connected to negative edge of the second clock pulse, right? Now what is this value? Exactly 0. Now this value will change from 0 to 1 or not? Try to identify, right? So what is the answer? The answer is that this will change to 1. Why it will change to 1? Because here output is 0, negative edge is detecting the 0. 0 means whatever the output value stored in the second flip flop, that will change from either 0 to 1 or 1 to 0. Now what is the answer? Answer is 1 at QB. Now after applying the third clock pulse, what will be happen? This value will be always changes, right? So what is the answer here? 1. Now this, what is the value here? It is detected 1 of the QA. This will go to negative edge. Now 1 is negative edge, it will change or not? It won't change, right? 1 means it won't change. Now what is the current output value? 1, right? The same value we are copying here, right? Now after applying the one more clock pulse, nothing but the fourth clock pulse value, what will be happen? So always it will change from 1 to 0, right? So value is 0. Now see that what is the value here? It is detected 0. 0 means negative edge will trigger or not? Yes, negative edge will trigger. What is the current output value? 1 means it will change to the opposite, 0. Now what is the answer? 0. See that initially 0. After applying the clock pulse, first it is changing from 0 to 1, then 1 to 0, then 1 0 to 1 1. Finally again it is returned back to the initial position, right? So this is how it will be work. Now I'm not going to explain so how to design the down counting operation. So how to design the down counting operation means, if you connected QA bar to this output, then it is called as the down count. It means you will be getting the output. First one is 1 1, next one is 1 0, next one is 0 1, 0 0, again 1 1. So this is nothing but QA QB. This is nothing but the clock pulse. Initial value no clock pulse, first clock pulse, second clock pulse, third clock pulse, fourth clock pulse. Remember, QA connected to the clock pulse of the second flip flop means this is up counting. If QA bar is connected with the negative edge of the clock pulse means it is called as the down counting. Operation everything is same, only how we are connecting the clock pulse only depends. So once it is completed, the final representation is that we need to draw the timing representation, right? So timing diagram. So how to draw the timing diagram means, if you understand here, the output of QA depends upon what? First clock pulse, right? The output of the QB is depends upon what? Second clock pulse, right? Just here. First I am going to consider the external clock pulse value. External clock pulse means what? Something. Sequence continuously changes, right? 0 to 1 or 1 to 0. Right? Now which level triggering, which edge triggering we are taking? Negative edge triggering we are taking, right? So negative edge means what? Falling edge or negative edge, as we discussed in the previous classes. Now identify the negative edge. This one is negative edge. This one is the negative edge, negative edge, negative edge, negative edge, negative edge. Now starting the time period, what is this one? This is the one time period. This is the another 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 time period. Now see that output of the QA is what? Depends upon the first clock pulse, right? So this is also clock pulse for the second flip flop, right? It means that this is the clock pulse of external. Now we need to find out the output of the QA, this one. After finding the output of the QA, we need to find out the output of the QB, right? So output of the QA depends upon what? Clock pulse of the external. Now see, this is also clock pulse only. Clock pulse means value should be changes from 0 to 1 or 1 to 0. Now see that where operation will be begins? From here only operation will be begin. Before that, what is the answer? Here only if operation begins means before that value will be nothing, right? It means that here answer is 0. If clock equal to 0, what is the next clock value? 1 up to where? At this time period. Now after 1, what is the value? It should be 0. After 0, what should be value? 1. Clock means continuous 0, 1, right? The same thing here I am going to write. So 0, 1, 0, right? 1 something, right? Sorry, I have done mistake. This is 1, this is low value 0, this is 1, this is 0, this is 1. Now what is the output? We need to find out QB, right? So how to find out the QB? If you see that QB is nothing but this one, right? It is depends upon the output of the QA or external clock pulse. Try to understand. The output of the QB is depends upon this clock pulse, right? Where it is clock pulse is coming from QA, right? So it means that output of the QB is depends upon the QA, not depends upon the external clock pulse. It means that if you want to find out the output of the QB, it is the depends upon the QA, not from the external clock pulse or main clock pulse. Now which we have to take the reference means for QB we need to take the reference as the QA, not the clock pulse. Why? QB is depends upon the QA, not on the external clock pulse. But if you want to find out the output of the QA, which one we need to consider? External clock pulse. It means that QA depends upon the external clock pulse, QB depends upon the QA. It means that for QB we need to take the negative edge. This is the negative edge, this is the negative edge. So it is the starting time period, this is in. So before this one answer is 0, next is 1, next is 0. So 0, 1, 1, 0, 0 something. So this is how we need to draw. So if you understand here, this is negative edge, negative edge, negative edge, negative edge, negative edge. So before here only it is the starting the operation, right? Before this value will be 0, from here to here value will be 1, then from to here value will be 0, from here to here value is 1, from here to here value is 0. Next for this one, this is the negative edge, right? So here only the value is starting ending, right? So before this is answer is 0, next 1, next it is 0, right? So this is how we are going to design the asynchronous counter. What is the first point we have discussed here is that first one is identification of the flip-flop. Mod 4 means we have the 4 stages. To store the 2-bit information, we require the 2 flip-flop. Asynchronous means first flip-flop will be triggered by the external clock pulse and the remaining flip-flop will be triggered by the output of the previous flip-flop. Now one more thing, if you want to change the count from 0 to 1, 1 to 2 something, then it should perform the toggle operation. This can be performed either in JK flip-flop or T flip-flop. So when j equal to 1, k equal to 1, then you will be getting the toggle. For second flip flop also jb kb should be 1, then only you will be getting the toggle condition, then only it will perform the asynchronous up count operation. Once it is completed, next we have seen the operation, then finally we have drawn the timing diagram representation, right? So if you understand this one, you can design any kind of the asynchronous circuit. Thank you.